Hello everyone. Welcome once again to another Power BI related tutorial by Team SlideScope. In this part we are learning how to create this simple exploratory data analysis dashboard which is about ocean, climate and marine life data set where we have total number of species samples received location wise and marine heat wave occurrences by location. We also have relationship between pH level versus the sea surface temperature, the minimum and maximum sea surface temperature by different years that we have. Obviously, we can use these drill downs to understand the values. Like you can see for different quarters, you can see for different months or days in particular. So this is something that you will learn from here, or you can just see it for different years. Next, we also have total number of species that are observed in that particular location and their relationship with the sea surface temperature, so, which you can see is decreasing when temperature increases. So, and coral bleaching severity distribution is also given there. Then we have these type of simple interactive filters, like you can select a particular location and see data over there. You can compare multiple values like this. So all of this along with these simple KPIs, we will learn how to prepare a simple dashboard like this, and along with this we will also do exploratory analysis and explanations of what is happening over there. So let's get started with it. So the data set that we are going to use in this project is this realistic ocean climate data set. Information about this data set is given here. This is known as shifting seas, ocean climate and marine life data set. And it is given as climate change accelerates, the world's oceans are experiencing significant transformations. And this data set compiles synthetic yet realistic measurements of sea surface temperatures, pH levels, coral bleaching severity, and species observations from ecologically critical marine zones. And the information that they have captured is from 2015 to 2023 and simulates how marine environments are responding to global warming. So this particular dataset can be used to train machine learning models to predict coral bleaching, visualize changes in marine biodiversity over time, detect climate-driven marine heat waves, and simulate the impact of ocean acidification on ecosystems. In the dataset, we have date, location, marine location name, latitude and longitude of that location, sea surface temperature in degrees Celsius, acidity level of seawater, lower means more acidic pH level. It is a sign of acidification. Bleaching severity categorical value, which is none, low, medium, high. Species observed, count of marine species observed during the sampling period, and marine heat wave. It is a Boolean flag which is true or false, indicating whether the sea surface temperature that is given here, whether it's greater than 30 degrees Celsius. So you can simply download the data set from here. You will get this CSV file, and you can use this CSV file for machine learning and data analysis projects. To start analyzing the data set and to create a simple interactive dashboard, we will use Power BI here. In Power BI, we will click on Get Data Text CSV, as the file that we have received from Kaggle is a CSV file. From here, click on the CSV file, open and connect it. You will see all the columns are properly matched with their respective values, and hence we can load the data. But before, we can go to transform. In transform, we can see the data type. For example, this first column is given as date, which is correct. Location as ABC, latitude is given as a float or a decimal value, longitude as well. Temperature is also given as a float value, pH level is also a float value. Categorical values like bleaching severity is a string. Species, number of species observed is integer, and marine heat wave, which is either true or false, is given as boolean. So now we can simply close and apply. We don't have to make any changes or change data type here. And now we have the data set. Here date hierarchy is given, which means that date is being read properly here. Next we will add a simple text box here, and in this text box we will add what we are trying to do here. So here we are using ocean climate and marine life data set. We are creating a dashboard. So we will simply put this title, align it to center, choose a font size of around 28, and we can choose this particular color. So we have set up the header here. In header we will go to effect. That is something that we usually do. I usually do. It's your choice. We enable visual border here. Select some color for border. Let's select the same color as font color, and select 12 pixel for rounded corners and enable shadow. So this is ocean climate and marine life data set. We are building the dashboard. We can save this particular data. We can go to device, and in shifting keys we will save it as EDA dashboard. Now we will simply shift this particular heading to right hand side and give some gap from top. This particular area which is on left hand sidebar right now, we will use this particular area for creating filters. So let's add some relevant image here. So we can go to insert and click on image to put some image here if this is optional. I will use this simple ocean species image here just on sidebar, and we will use the same styling as here. So click on home, and we will use format painter to use the same styling. So we have the data prepared, like our dashboard is now ready. The initial part like headings and image, whatever you need to put here. Now what we can do, we can simply start creating some KPIs. For example, we have pH level, we have species observed, and we have sea surface temperature. So we will use a simple card here to see some parameters. So let's create some cards here. Here first of all I will bring the sea surface temperature. So first of all I will go with maximum sea surface temperature. In the visual setting in callout value, I will use only 25 pixel because we may have to bring more cards here. So or 30 will also be okay. So this is 30, and this is maximum of sea surface temperature. In callout value I will choose a different color, and for category label also, which is this value, we will choose a bold font. We will go to general tab, effects, and we will enable shadow and visual border here, and we can increase its height a little bit. If you want to give it a curve effect like we have done, so in visual border we can select 12 pixel as rounded corner, and then we have this value. So this is maximum of sea surface temperature. Then we can also do a minimum value. What is the minimum of sea surface temperature? Similarly, we can also go with, we'll make two more copies, and in pH level also we can do the same thing. We can also go with average value, so that is something that you can do as well. So minimum pH level is 7.87 in the sample that we have, and here if we go with pH level, the maximum pH level is 8.20 in the samples that we have. This way you can prepare your cards, and let's see how many total species have been observed here. So total number of species observed, here we have to use sum, and we will rename is this as number of species observed. So whatever, suppose you want to see average, minimum, maximum, everything, like you want to describe each and every variable that we have here separately, so you can do that as well. Now our KPI row is prepared. Whatever you need to put more can be here. This particular area which we have kept for slicers or filters, so we will add a slicer visual here from Power BI. In the slicer visual we will have, so we will make its height equal to height of the card. We will apply the same styling here. In the field we will first go with bleaching severity, and in slicer setting we will go with a drop down. So this way we will have a drop down. Let's say when the bleaching severity is high, then what is maximum temperature, minimum temperature, and how many number of species are there in low, in medium, and in none. So as per the dataset description that we have here, so as per the dataset description, when they have instructed about train ML models to predict coral bleaching based on temperature, so we can use this particular variable as our target field also. So that's why this is very important. One more thing, in the slicer setting that we have here, we can make the slicer header bigger so that it is properly visible, and we can choose a different type of font color for it. If you want to make it bold, you can choose. Then in slicer values also we can select a different font color, and we can increase its size a little bit. So now we have the slicer ready with bleaching severity as our first categorical field that we are using as a slicer. Next is location, so we can make a copy of it. This way you can reuse the elements again and again. Here we will simply use the location. For example, if you want to see for Caribbean Sea, what is the, what are the total number of species, from the samples that we have, maximum pH level, minimum pH level, what is the average pH level, we will see later. Great Barrier Reef, Hawaiian Island, you can see temperature is 30.76. In Maldives it is 30.92. In Red Sea it is 31.46. Where it is more, where it is less, that is something that we will just create some visuals and see. Then we also have marine heat wave, whether it's true or false. So you can see uh, in marine heat waves also we can use as filter here. So in case of marine heat wave is false, you can see maximum temperature is around 29.9. In case of true, it is more. If you have other categorical fields, you can select them. What I want to bring here is, I also want to bring quarter or month here, like in which particular quarter do we see higher temperature range, higher pH value, So for that, what we can do from the date hierarchy, we can bring the quarter value from here. We have quarter 1, 2, 3. Let's say in quarter 1, you can see maximum 31, minimum 27. Quarter 2, 30.60 is maximum. Quarter 3, it is reducing. And quarter 4 also, maximum temperature is low. You can see quarter wise also. You can see in quarter 1, temperature is higher in the samples and it is reducing as we are increasing towards December, right? So this is something you can do. In the same way, you can also include month or year also. So this, let's create a simple copy of it, and we can also add month here. And whatever fields we are using for are using as a filter here, these will be the fields which we are thinking that these fields are affecting our target fields. These fields are affecting our target field like marine, this particular bleaching severity. Okay, these fields may be affecting bleaching severity. If let's say our concern is temperature rise and fall, let's say we want to analyze that. So in that case also we can see how these different factors are affecting our overall temperature, overall bleaching severity, etc. So we will put those charts one by one. If you want to learn Power BI, you can learn at slidescope.com. Now, one thing that I want to see is, because we have values from 2013 to 2015 to 2023, maybe 2013 to 2023, and we want to see over these years if the temperature, if there is a temperature rise or fall. So what we can do here, we can create a simple line chart here. The width of this line chart, I will choose 1.5 the width of these cards, and I will just use its height, maybe half of the chart or maybe this much which it is suggesting. And here what I will do, on x-axis I will put date, which will automatically bring year, and then on y-axis I will put the average temperature, the average sea surface temperature. So you can see over the years, in 2015 it was higher, but first of all we have to select average, not minimum or maximum but average. And in temperatures you also see sometimes a minimum and maximum value is also given. So let's say, what if we do a minimum here and we create another copy of it and put maximum value. So we will have two lines. So minimum temperature is blue, maximum is this. You can see over the years, and from this year onwards, that means from 2016 onwards, it was on rise. Then after 2020 it decreased. And now what we can do here, we can simply go to general tab, title, and we can write minimum and maximum sea surface temperature by year. So this is something that we can do, and we can select a color like this, probably make it bold and align it to center. For this chart also we can select, we can go to general tab, effect, shadow, border, select border color, make it rounded. So this is minimum sea surface temperature by year, minimum and maximum. We can click on this particular arrow to turn on drill down, and then if you want to go next level, so if you want to see it quarterly, monthly or daily, you can see that. Okay, let's go up. This is monthly data. So in monthly you can see average, you can see the minimum temperature, maximum temperature in the month of August, Actually, maximum in terms of August is highest, and in terms of January, maximum is highest, which is given here. It is minimum in the minimum of maximum is in the month of May. This is as per the data set. So this is one thing that we can do. We can again click and go back to year level and click drill down, and then we can click this particular arrow also to see the temperature like this. So here you can see to year wise you can see properly, right? So 15, 16, 17, 18 and 23. So this will tell us how the temperature has varied over the years. So this is something that you can do, and if you just want to see it as a summary, by default it will show like this. So you can, since it's a interactive report, so you can use these particular charts to interact with the dashboard. Now we will copy this, and after making after copying this we will put it here. So the other thing that we want to analyze is sea surface temperature versus pH level. So we want to analyze what is the relationship between sea surface temperature and pH level. You can see we have a range of pH level, we can see we have a range of temperature, but if we compare it with sea surface level, so for that we will use a scatter plot. So we'll select this and just select the scatter plot. Obviously it will not accept these fields, so for that we will put pH level on the x-axis and we'll say don't summarize, and we will add the sea surface temperature on y-axis and we'll say don't summarize. So you can see as per the trend that is given here, when the pH level is increasing, you can see a decline in sea surface temperature. So as per the data set, in Power BI there is this particular icon which says add further analysis to your visual, where you can enable this trend line. So this trend line will help you in understanding whether when x-axis is increasing or decreasing, what is happening to the y-axis. So here the graph title will be different. So this will be simply pH level versus SST, sea surface temperature. Now there is one more thing that we can do. We also have heat wave here, marine heat wave, which is given as either false or true. So we want to segment them. So here we also have a legend field. In that legend field we can bring something that is categorical. So we will bring this marine heat wave as legend, and then you will see that you can see the temperature which is higher than 30 degrees Celsius. For temperatures that are higher than 30 degrees Celsius, marine heat wave is true, and below that it is false. You can see these light blue colors and dark blue colors. So this is how you can see. It can be a reverse also, like if you want to see if temperature increases, will that increase pH level also. So we can just do it like that also. So here also you will see the same thing, and here also you will be able to see this dotted line for 30 degree. So whatever you want to analyze, you can do it like this. So next thing that we want to analyze is marine heat wave occurrences by location. Okay, but before we proceed, I will just go to transform data and I will add one index column over here. So because for all the samples that we have, we don't have any sample ID here. So we'll go to add column and we will go to add index column from 1. So this will simply add an index column. We will go to home tab from here. So we will go to home tab. So this is add column, and now this is home tab, and we will simply close and apply. So here you will be able to see that one index value is now there. This will help us in finding out count of records, right? Number of records. So obviously we have number of species observed, but we also want to see number of records in which marine heat wave. We want to count number of occurrences where marine heat wave is true. So what we will do, we will create a simple clustered bar chart here. So first we will make a copy of it. Later we will adjust the widths here. So first we will make a clustered bar chart. Let's remove this, remove everything from here. So here on y-axis we will put the location because we want to see marine heat wave by location. So we will go to visuals title and just say marine heat wave occurrences by location. So that's why on y-axis, because you can see it's a cluster bar chart, you can call it a horizontal bar, right? So in horizontal bar on y-axis you will put the categorical field. If it was a vertical bar, then on x-axis we would have put the same field. So that is very important. Now after putting it here on x-axis, we have to do or write something that can count something, right? So we will use index that we just created, and we will use count of index. At this moment you can only see Red Sea because only Red Sea is selected. When you will see it for all locations, you will be able to see more samples here. So you can see marine heat wave occurrences by location. We have Great Barrier Reef, we have Red Sea, and so on. We can increase the width of this particular chart also so that we can see more visuals over here. And let's align them. Now here actually whatever we are seeing, so in this case it is for all cases. Now let's say you just want to see it for marine heat wave true. So you can see marine heat wave occurrences by location. In the South China Sea we have most number of occurrences of marine heat wave, then in Caribbean Sea, then Red Sea, then Hawaiian Island, then Galapagos or however you pronounce it, and lowest are in Maldives. So this is how you can do that. But let's say we don't want to do it for all the charts, right? We just want to do it for this particular visual only. So here you can go to filter, which will show filters on this visual. Here we have location is all, count of index is all. This is all good. We will just add a field here and say marine heat wave is true. Okay, so it will every time it will show the same thing. Whether even you select false, so it will not appear. Okay, so that's how you can do this. Now we can create a copy of this because in the next row we will put more visuals, and once we are creating we can see we have some gap over here, so we can increase height of these two visuals little bit and keep a little bit of gap between them. So let me fix that quickly. So this much will be okay. So here if we go to general and properties, its height is 245. So we can make the height of everything as 245, all other visuals as 245 to make all of them look of equal size. Same here, we can go to properties, height 245. We can go to properties, height 245. Here maybe it is less, so that's why. Let me select, yeah, 245. It's okay. Now there is one more thing. When we are showing data like this, we can go to visual settings. We have bars, and in bars we have a color. So we can select this FX, which is conditional formatting, and we can select the gradient rule. So obviously the numbers that we are counting are through count of location. So if the count of location has a lower value, it will be displayed using a light shade color of blue, and highest value with a dark shade color of blue. So you will be able to see it like that. And count of location range is from 7 to 16. This particular value that we are seeing here is called legend. So we can go to visual setting and disable the legend. So this will show the data like this. Now we also have the bleaching severity, which is the coral bleaching severity. So we can go to the, first we will change the title. We will see coral bleaching severity distribution. We can see total number of cases in which we have with coral bleaching severity, like how many cases have high, low, medium or none. So here what we will do, first of all we will create a simple stacked column chart. We will get rid of this. In x-axis, see, because it is a column chart, it is not like a bar, so it is not a clustered bar, it is a column, a vertical bar. So here on x-axis we will put the categorical field, and on y-axis we can simply count total number of values. You can see we have none here. So first of all what we can do, we can go to filters and say we don't want to see none. We want to see the cases where we don't have none. So then you will have medium, low and high. And just want to show you here, as we used gradient, so we can go here. Here also we have columns and we have color. So let's say medium, we want to show medium by this color. We want to show low by this color, and we want to show high bleaching by this color. I'm just showing you three different options. So this is something that you can do, right? It's up to you, but this is how you can show total bleaching severity distribution. So this is something that we can do, or we can again go in this also. We can go to columns, and here also we can select all, and then we will have this FX ready. So here also we are going with gradient. So we will say lower value light blue, higher value dark blue, and middle value yellow color. We can do something like that as well. So this will show medium, low, high, and here we can, let's keep the legend this time, just to make you understand that we can keep these things. Now as we created a simple graph like this, where we saw the relationship between pH level and SST. Let's see, if we increase or decrease the sea surface temperature, will the number of species increase or decrease? So here on y-axis we will put number of species observed, and here we will not use marine as legend here. So, and we will use this as don't summarize as well. So you can clearly see, as per the number of samples that are received, that when the sea surface temperature is increasing, species observed, total number of species observed are also decreasing. So how it is affecting, that is something you can see from here. So what we can do here, we can also, first of all, let's change the title. So this is species observed versus SST. And here as a hue or as a legend, like as a color. We can include marine heat wave, we can include count of bleaching severity or location, whatever you want to observe. So for example, we can also include bleaching severity here. So you can see high, low, medium, none, and we can obviously remove none from here. So we will select all but none. So this way we will have this particular chart over here. Obviously, when we add high, low, and medium bleaching severity, so this is not very clear that on the basis of this particular relationship and adding this hue, we cannot get significant information. So if you want, you can remove others, but when we are using this small chart here, we can see most number of cases of medium are in which particular range. So we can just keep it like this. Next, we will create a very simple chart which will show us locations by their average temperature. So we can create a simple matrix. Let's try to create a matrix chart. So in columns, we can put location here, or let's add them as rows. Just a minute. Because we want to see their value, their average temperature value next. Now in values, we can write average sea surface temperature. Instead of sum, we can write average. And then we can go to visual settings, where we have cell elements, where we can enable data bars. So here you can see, because all the average temperatures are pretty similar to each other, that's why these data bars are also of equal size. Next, we can also go to values. So in values, we can increase values, and then we have this location wise average of SST. We can include row headers size also. So we are just doing it so that we can fit the width here. So this is location average SST, and for different locations we can see that values, and we can copy the same formatting here and apply it here. So this is a simple dashboard, a simple interactive dashboard that is helping us in analyzing this ocean climate and marine life data set. It is helping us in analyzing how over different years temperature has changed, what is the effect of pH level on sea surface temperature. You can see in which particular location we have the highest average temperature, which is in, so you can click on it to arrange it as well. So in South China Sea it is highest, and then you can see in the same way like in South China and Caribbean, because these are related, so their marine heat wave occurrences are also more. So you can use this type of data set for exploratory data analysis and understanding Power BI concepts. I hope you like this tutorial. If you did, then please like this video, subscribe to our channel. If you have any questions or suggestions, please ask them in the comment section. Thanks for watching this video. Have a nice day.